Okay, so we need to be able to factor just about any kind of problem, but we need to recognize some quick ways of factoring. And one of the quickest things that we can see from this particular equation number 1 is that we have a perfect square here and we have a perfect square here, and they're being subtracted. So this is the difference of squares. So the difference of squares tells us that we can simply create our factors by taking the square root of each of the perfect squares. So I'm going to take the square root of 4r squared and I get 2r, and I'll put it over here in this factor as well. The square root of 9 is 3, so I'll put it in there. And then because we don't have a center term here in our equation, we know that we have to have one negative and one positive sign so that it eliminates the center term. So let's just distribute these real quickly to make sure that we have the right answer. So 2r times 2r is 4r squared. And then we have 2r times 3 gives us a plus 6r. And then we have a negative 3 times 2r, which gives us a negative 6r. And then a negative 3 times a positive 3 gives us a negative 9. Now these two terms will cancel one another, and so we're left with 4r squared minus 9, which is what the original problem was. So we've concluded that this is the right answer. So problem number 3, we should recognize it as a perfect square, and even problem number 5 just below it is a perfect square, and it's a difference between those two perfect squares. So each one of them will work the same way. So again, we can identify the our factor parentheses, and we're just going to take the square root of each of our two perfect squares. So here, 16 times a squared, the square root is just 4a, and so each factor is going to have the 4a in it. And then the square root of 9 is 3, so each factor will have a 3. One is going to be a positive and one is a negative. That creates that negative when we multiply those two numbers together. And then, of course, by having a positive 12a and a negative 12a, we no longer have a center term. So our answer to that one is just these two factors here, 4a plus 3 and 4a minus 3. So number 5, we would do the same thing. So we can take the square root of each of our perfect squares, and so for 9p squared, it's just 3p. For 1, it's just 1. And because it's a difference of squares, we can use, a positive and a negative. And so when we distribute, again, we get 9p squared. Then we get our 3p times negative 1, which is negative 3p. Our 1 times 3p, which is a positive 3p. And then our 1 times negative 1, which is a negative 1. Again, these cancel out, and so we're left with 9p squared minus 1, minus 1, and that indeed is the problem that we started with. So we know that our solution is indeed these two factors. These problems look a little bit more difficult, but quite frankly, they're the same thing because we notice that we have a perfect square and a perfect square, and we have the difference between perfect squares. Down here in number 11, we have a perfect square and a perfect square and a difference between perfect squares. So again, we work it the exact same way. So we identify our factors by getting our square root of those perfect squares. So 25x squared is just 5x, and that goes in each one of the new factors. And then 4y squared is 2y. And now we just, because of the knowledge of difference of squares, we can say one of them is going to have a positive, one of them is going to have a negative. And if you FOIL that out or distribute that, you will find out that that indeed gives us back 25x squared minus 4y squared. Down below in number 11, we can do the same thing, create our factors, and we take the square root of the first term, which is 3x, and that goes in each factor, and we take the square root of the second term, which is just y, and that goes in each factor. One gets a plus, one gets a minus, and if we were to distribute those back together, those two factors, we would indeed get the problem, the 9x squared minus y squared, as the answer to the distribution.